Hi everybody. In this video, we're going to look at a product rule of differentiation. In example 1, I'll show you how we can prove this product rule when we've got y as a product of two functions of x, u and v. To derive this product rule, we need to go back to differentiation by first principles. This is where we add a small amount onto each of these two functions of x. So if we add a small amount to u, we'll call this small amount delta u, and we'll do the same for v. The small amount now will be delta v. Well, a small increase in u and v will lead to another small increase in y. So this will be y plus delta y. Now we can expand out each of these brackets. So y plus delta y will be uv plus u delta v plus delta u times v, or v delta u, and delta u times delta v. We can replace this y with uv. So uv plus delta y will equal uv plus u delta v plus v delta u. Now if delta u and delta v are both small increases, when you multiply them together, delta u delta v will tend to 0. This will become very, very small. So we can cancel this term out. And you can see that this uv will cancel with this uv. So delta y will be u times delta v plus v times delta u. Now we can divide both sides by delta x. And as delta x tends to 0, delta y tends to dy, delta v tends to dv, delta u tends to du, and delta x tends to dx. So this equation becomes dy by dx will equal u dv by dx plus v du by dx. And this is the product rule here. So as we progress through this video, I'll show you how to use this product rule to differentiate two products of x. Let's try example 2. So we're given that f of x is x squared multiplied by the square root of 2x minus 3. And you can see that these are both functions of x multiplied to each other. So we can use the product rule. If we let u equal x squared, so this term here, then du by dx will be 2x. And if we let v equal the square root of 2x minus 3, I'll write this as a power, then dv by dx, using the chain rule, will be 1/2, bringing this power down. Lots of 2x minus 3 to be negative 1/2, taking 1 away from this power, multiplied by the derivative of this inner function, multiplied by 2. We can tidy this up, so dv by dx, this half and this 2 will cancel. The negative will give us 1 over 2x minus 3 to the half, or square rooted, okay? So we've got u, we've got du, we've got v, and we've got dv. Now we can substitute them into a product rule, where dy by dx will be u times dv. So 1 over root 2x minus 3 plus v, which is given here. I'll write this as the square root of 2x minus 3 times du, which is 2x. Now we can add these two terms together if we have a common denominator. So I need to give this second term a denominator of 2x minus 3. So I need to multiply the numerator by that same term. So dy by dx will be x squared over root 2x minus 3 plus When we multiply this square root by this one, the roots will cancel, and we've got 2x minus 3 multiplied by the 2x over our common denominator. And now we can write this as a single fraction, so we'll have x squared plus the 4x squared minus the 6x over the common denominator of root 2x minus 3. We can tidy up our numerator, so we've got 5x squared minus 6x over root 2x minus 3. Okay? So this is the derivative of f of x. Let's try example 3. So we're told that a curve has the equation x plus 4 squared multiplied by e to the 2x. Do you want to try and work out dy by dx using this product rule? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. If we let u equal x plus 4 squared, then du by dx, using the chain rule, we'll bring this down. We'll get 2 lots of x plus 4 to a power of 1, multiplied by the derivative of this inner function. We multiply it by 1, so we just get 2 lots of x plus 4. And v will be e to the 2x, so dv by dx will be 2e to the 2x. So dy by dx will be the u term, x plus 4 squared, multiplied by dv by dx, 2e to the 2x, plus the v term, multiplied by the du by dx term, which is 2 lots of x plus 4. Now you can see we can factor out the x plus 4, we can factor out the 2, and we can factor out e to the 2x. So dy by dx will be the 2 e to the 2x multiplied by x plus 4. We need to make this square term, so we need another x plus 4, and we need a 1 to make this term. So dy by dx will be 2 lots of e to the 2x multiplied by x plus 4 multiplied by x plus 5. Okay, how did you get on with that? Let's try one more question. In example 4, we're given that f of x is x to the 4 times the natural log of cos of x. We need to show that this is the derivative. Do you want to give this question a go yourself? Okay, so welcome back if you had a go. So if we let x to the 4 equal u, then du by dx will be 4x cubed. And if we let v equal the natural log of cos of x, then using the chain rule, dv by dx, this will be 1 over cos of x. So we differentiate this bigger function, then we multiply it by the derivative of this inner function, and the derivative of cos of x is negative sine of x. So dv by dx will be negative tan of x. So dy by dx will be the u term multiplied by the dv term plus v times du. Now we can factor out the x cubed, so dy by dx will be x cubed, and I'm going to write this term first because I don't want to start with a negative. So multiplied by 4 times the natural log of cos of x minus, we need an x term here, tan of x. And that's what we were asked to show here. Okay? Well, thank you for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.